Hi, Year 12. We're looking now at the next topic, which is series with finance. I'll just pop up to the top of the sheet there. That's the booklet that you should be working for at the moment. The booklet's got on the next page all the formulas that we looked at in our previous topic, and these are all on our HSC formula sheet. The only difference is the little infinity down there isn't on the sheet. So it's good to still know that is infinity, and I generally like to write it on that sheet. I have not explicitly done a video for 8A. It's very simple and fairly straightforward, and I think you can follow that through my notes and let me know if you can't. The part here that I've got the line through, we are not doing. It is not an advanced part of the course, although it is in the textbook. It's not part of the syllabus, and it's a little bit too hard, and there's little tricks in there that are non-algebraic. So we don't need to know it for the HSC, so we're going to remove that part. We're going to have a look at 8B, the use of logarithms with GPs. Okay, so geometric series or sequences are described by exponential functions. Because if you think of what the formula is for the term of a GP, the formula is, the term of n is AR to the n minus 1. So we've got a power of an unknown, which gives us an exponential. So in order to solve for specific n values, we need to use a logarithm. Because if you remember what our log laws were, when we had an unknown power, if we can take the log of both sides, or take the log of something, we can bring that power down the front. And so that's why we're going to use the logs, because the unknown can come to the front of our equation, and then we can solve for it. Sometimes we need to change the base rule. I generally don't use it because we can take the log of both sides and it works out anyway. Occasionally, what we can do in this topic is a guess and check approach. That is also acceptable in a lot of circumstances. So don't forget that could be used for us as well. Okay, so let's have a look at the first question here. And it says to use logarithms to find the smallest such integer n, integer is just a number, whole number in this case, such that 2 to the power of n is greater than 50,000. Okay, so like I just said, when there's an unknown power, we need to log both sides, and that's what I'd like you to do in these equations. I don't want you to try and rearrange the exponential into a log because it's an inequality sign. So we've got 2 to the power of n is greater than 50,000. Let's take the log of both sides. The natural log, log here, log here. That n can come down the front. So I have n log of 2 is greater than log of 50,000. Now, because we've got greater than or equal signs, we know that when we divide or multiply by a negative, we need to flip the sign. So what you need to make sure you're careful of doing is checking that the thing we're dividing by, in this case, is log of 2. Check that it's not negative, because occasionally the log that we're dividing by is going to be negative, and so we need to flip the sign. Okay, log of 2 is not negative, so my inequality stays the same way. So I've got n is greater than log of 50,000 divided by log of 2. Now they're natural logs, you can pop those in your calculator, and you'll end up with n is greater than 15.61. The question said the smallest integer. We need a whole number. So the next whole number that's bigger than 15.61 is 16. So that's one way to do that. There's also another way, and I've done that in green over to the side here, and it's just by trial and error. So just figure out what your powers of 2 are, because I've got 2 to the n. Let's find whole numbers of n and find the first number that is actually bigger than 50,000. So 2 to the 5 is 32. It's definitely not big enough. I've jumped up really quickly to 2 to the 15. Gives me 32,768. Now, here's the one we want. 2 to the 16 is 65,536. So this one, this 16 is the first number that gets our value bigger than 50,000. So n is 16. So in that case, that's totally acceptable in the advanced course to use that kind of thinking in some of our questions. Okay, let's have a look at the next one. I've got to think a little bit about this one. It says the profits of a local cafe have been increasing. So we want our values to be going up, and they're increasing each year since it's been opened by 12%. Now, 12% we write as 0.12 when we get rid of the percent. In the first year, the cafe made $15,000 profit. So I've written the series down here in blue. I've got 15,000. It's increased by 12%. So I've got 12% of 15,000, then I've added on to the 15,000. So my next term is 16,800. So what we can actually do is either write your series out and work these values out, and then work out our R by going 16,000 divided by 15,000, which I've done here, and get an R of 1.12. But what we can also do is go, well, when it's an increase, we're going to add the percentage increase to 1. So 1 plus 0.12 is 1.12. So you could think of it like that as well. If it was a decrease, we'd go 1 minus 0.12 and we get 0.88. So depending on whether you understand this increase or not, or whether you want to just work the series out and find the R, both are totally acceptable in this case. The question says to find a formula for its profits in the first year. Now the sequence that we've got here is showing the profits. So we want to find a formula for the profits in the nth year. That's going to be just a term formula. We want the term of a GP, which we've got there. We're just going to pop our A in, we're going to pop our R in, and that's the formula that we want. So that one's fairly simple. Now the second one, we're going to look at logarithms. The second part says, during which year did the profits first exceed 50,000? So which term is bigger than 50,000? That's what we want. T to the n is greater than 50,000. We worked out T to the n up here. So I've popped that in here. Find out for which n here, that formula is bigger than 50,000. So I've divided by by 15,000, and I've neatened it up to this. I've left the fraction as a fraction instead of a decimal because it is a reoccurring 3.3 repeater, and we don't want to round. So let's leave it as 10 over 3. I've taken the log of both sides, and then what I've done is brought the n minus 1 down. I've done it in one step and then divided by the log of 1.12. So there is a step between here and here. What you then do is pop this on your calculator and add 1. So I've got n minus 1 is greater than 10.623. Add the 1. I get n is greater than 11.623. It has to be a whole number. N is 12. So it's the 12th year that our value first exceeds $50,000. Let's look at the next one. Part C. It says find a formula for its total profit. Now total profit is telling us it's a sum. We need to sum things up. So you're looking for the words in there to figure out what you need to do. So sum. There's our sum of a GP. Now I've picked this formula as opposed to the other one because our ratio was bigger than 1. It's 1.12. You need to be careful which formula you pick. And what I do to check if I forget which formula is I want my bottom line to be positive. So if I have got this formula, I've got 1.12 minus 1, and I've got a positive number on the bottom. If I'd used the other formula, which was 1 minus r to the n, and the bottom was 1 minus r, I'd get a negative number on the bottom line, which I don't want because it's going to mess the values up. So that's how I check if you're not sure. That's the formula for here. I'm popping my values straight in, and what I end up with is 125,000 times 1.12 to the n minus 1. That's the formula, and I've just rewritten there. It's a generic formula. The next one, we're actually going to figure out a year that goes with it. So during which year did the total profit since opening exceed 100,000? So we want this sum from the previous question to be looking at that greater than 100,000. So I pop my formula in, pop the 100,000 in, and it's pretty much the same as the question that we did above. I'm going to divide by the 125,000 on this side to get 0.8, and then I'm going to add 1. So my formula becomes 1.12n is greater than 1.8. Now, if I'm talking too fast or you find that you're not sure what I've done, pause the video, go back and have a look. I'm just trying to shorten the lengths of the videos because I'm finding people are either not watching them or they're going for way too long. So just note that that's what I'm doing here. So with this part here, we've got an unknown power. We need to take the log of both sides. So I've done that over here. Or you can do trial and error again if you like. Taking the log of both sides means that we can bring that n down the front like this. Divide by the log of 1.2, just like this, and then pop that right-hand side into my calculator, and I end up with n is greater than 5.18565. We want n to be the next integer or whole number bigger than that, which n is 6. So the 6th year is the first year to exceed that 100,000. So you can see that we're doing the same thing over and over again. Okay, very similar for this next one. There's just a little trick in this one. I've highlighted this part in here just to have a look at it. I generally don't think of it like that, but just note that there are some little rules that we can look at with logs. I generally use a natural log will get us to use a log of base e, so we don't have to worry about these too much. Consider a situation where the sales of gum nut soft drink are declining. Okay, before it was increasing, declining 6%. 6% is 0.06. 1 minus 6%. Or 0.06, it's going to give us an R of 0.94. If you don't know that, you're going to work out the series and work out the ratio from one term to the next, and that's the R that you're going to get. So they're declining. 50,000 bottles were sold in 2016, during which year will the sales fall below 20,000? So we've got A is 50,000, we've got R, which is 0.94. We want to figure out which term is less than 20,000. We're not looking at a sum in this case, so just be careful that you're getting the right formula. So there's my term to end formula. I've popped that in there with my values that I have above here, and I want that less than 20,000. So like before, divide, neaten up, take the log of both sides. Okay, and I'm up to this part here. Now there's something that I need to do differently in here because, I've brought the n-1 down. Log of 0.94, okay, is actually a negative number, okay? So what I need you to note that normally we just crazily just divide by things, and it's generally not something we've had to think about, but we want to start now thinking about when we are dividing in inequalities, is the number I'm dividing by negative? In this case, it is. So that inequality here has to flip the other way, otherwise we're going to get the wrong year. So that's the first time that we've come across that so far. The rest of it's the same. I divide, I add 1, and I get 15.88, and I end up with 16. If you had the inequality the other way, you'd get 15. So we've got to be, it's going to make a big difference to our answer. So 16 year is the first year that our sales fall below 20,000. And that's the end of that section. I hope that helps. I know I've talked fast, but I'm trying to cut these videos down to close as I can to 10 minutes.